Hello, this is Professor Cheban Acharya. In this video, I'll do the homework from section 5.1, and these homeworks are from MyLab math homework. First question is about the definition. Describe the difference between classical and empirical probability. The answer for this question is D. For the answer, you have to read the PowerPoints and the textbook definition. The empirical probability method obtains an approximate empirical probability of an event by conducting a probability experiment. To find the empirical probability, you got to conduct a probability experiment, but for classical probability, does not require experiment. And classical probability, in fact, based on the counting technique, and it requires equally likely outcome. Question number 2. This question is true or false question. Probability is a measure of likelihood of random phenomenon or chance or behavior. That is obviously true. That's the true. Question number 3. Fill in the blank. In a probability, N or A is any process that can be repeated in which the results are uncertain, and that process is called experiment. The experiment is a process that can be repeated in which the results are uncertain. Question number 4. Describe what an unusual event is. Should the same cutoff always be used to identify the unusual event? Why or why not? Unusual event is the event that has a low probability of occurring. I mean, if any event has a chance of occurring low, that is called unusual. Usually cutoff number for unusual event is going to be 5%, or probability of event, let's say probability of event which is less than 5%, as a decimal is going to be 0.05. If any event has a chance of occurring less than 5%, that is usually called unusual event. Therefore here answer is B, obviously, but the same cutoff should not always be used to identify unusual event. Okay, selecting cutoff is subjective and should be take into account the consequence of incorrectly identifying unusual event. Therefore the cutoff point should not always used to identify the unusual event, but generally we use 0.05 probability as a cutoff points for unusual event. Question number 5. What is the sample space of the experiment, and what is event? There's two questions. First question is what's the sample space? Second question is what's the event? And you'll find the definition in the textbook or PowerPoints or notes. This B is the answer here. The set of all possible outcome of an experiment is the sample space of the experiment, which is denoted by S. Notice that sample space is denoted by uppercase S, and event, usually denoted by E, is any subset of sample space. Therefore all possible outcome is sample space. The subset of sample space is an event. Question number 6. Complete the sentence below. Is the fill in the blank question. In the probability model, the sum of the probability of the outcome must equal 1. Therefore you type the integer as a 1 here. Okay. Number 7. is the following the probability model? What do we call the outcome read? And notice that for the probability model, all the probability must be between 0 and 1, and that's the criteria. In other words, the probability of event must be between 1 and 0. That is called probability of any event has to be between 1 and 0. Can be 1, could be 0. That's the first criteria. The second criteria called sum of the all probability. Sum of all probability equals to 1. And if you see this probability here, all probability are between 0 and 1, we good. The first criteria satisfy. The second criteria, if you add all the probability, the sum must be 1. Therefore, the answer to the first question is the table above an example of probability model? The answer is yes. The answer is yes. Why? Because all the probability are in between 0 and 1, inclusive, and sum of the all probabilities equals to 1. And what do you call outcome as read? Since the probability of read here, since the probability of read is going to be 0. What's that? 0. Oh, sorry, 0, which is 0. Therefore, if the probability is 0, the event is called impossible event. Okay, the impossible event is if the probability is 0. Therefore, outcome read we call impossible event. Question number 8. Why is the following is not the probability model? And here's a table, and you have a color as a event and probability here for each event, and this is not the probability model because now look at the probability of the green, which is negative 0.3. Then probability cannot be negative, therefore it's not probability model. Notice that for the probability model, probability must be greater than 0. Okay, but this is number negative 0.3 is less than 0, therefore this is not the probability model. The answer is D, because at least one probability is less than 0, which is probability of the green. Question number 9. Suppose you toss a coin 100 times and get 79 head and 21 tail. Notice that 79 plus 21 gives you 100. Based on the results, what's the probability that the next flip results in tail? Therefore, in this question, looking for probability of next flip as a tail. And for this question, you got to find how many tail on the 100 toss. You have 21 divided by 100, because there's total tosses 100 times, and the answer must be decimal, because instructions is type an integer or decimal rounded to 2 decimal places. Therefore, the answer is going to be 0.21. 0.21 is the probability. Okay, number 10. If a person spins 6 space spinner and then flip a coin, describe the sample space of possible outcome using 1, 2, 3, 4, 5, 6 for the spinner and outcome head and tail for the coin outcome. Therefore, you look is for the spinner. A possible outcome going to be 1, 2, 3, 4, 5, 6. For flip coin, the outcome is going to be head and tail. Therefore, the sample space is going to be, look at here, you have a curly braces around this box. You're just putting sample space. Therefore, you're doing this. You might get 1 with head, comma, 1 with tail, comma, 2 with head, comma, 2 with tail, comma, 3 with head, 3 with tail, and so on. And finally 6 with head and 6 with tail. That is the sample space in this problem. Question number 11. According to the certain country Department of Education, country Department of Education, 43.5% of 3 years old are enrolled in a daycare. In other words, 43.5% enrolled as a daycare. Okay, as a decimal, this is going to be 0.435. 435 as a decimal. And the question is, what is the probability that a randomly selected 3 years old is enrolled in a daycare? Since 43.5% enrolled in a daycare, the probability that a randomly selected 3 years old is enrolled in daycare is 0.435. Okay, this percentage is a decimal, which is going to be probability in this case. Question number 12. Let the sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is the sample space here. And the event is 4, 5, 6, 7. Okay, and the question is, compute the probability of the event E. The probability of the event E equals to how many number in event E divided by how many number in the sample space. In other words, how many outcome on the event E divided by how many outcome on the sample space. And you see that there is 1, 2, 3, 4 outcome in event E. Therefore 4 divided by there is a 10 outcome in the sample space, 1, 2 up to 10, 4 over 10, and the answer as a decimal is going to be 0.4, because in the instruction says type an integer or decimal, do not round. Therefore you put 0.4 here. Number 13 is similar to number 12, therefore I don't do that. Number 14. A survey of 400 randomly selected high school students determined that 265 plays organized sports. Notice that there is a 400 people they are surveyed on high school, and among them 265 plays organized sports. Okay, and the first question is, what's the probability that randomly selected high school students play organized sports? Therefore here, part A, we are looking for probability of students who plays organized sport. And to find that, you got to find how many people are in survey. 400 out of 400, 265 plays organized sports. And if you divide 265 by 400, and you'll get 0.663. Notice that it says rounded to nearest thousands. 1000 means 3 decimal. The answer is going to be 0.663. 0.663. And part B is pretty much interpret the probability. What do you mean by 0.663 probability here? That's the question. And the answer must be the B. In other words, if 1000 high school students were sampled, it would be expected that about, you have to put the number in the box, of them play organized sports. You multiply 0.663 by 1000, you get 663. In other words, if you select 1000 high school students, or if you sample 1000 high school students, there is about 663 play organized sports. About. So notice the difference between A and B. It says it would be expected. I say exactly. Since this is an interpretation of the probability, we don't do exactly. Okay, and therefore we choose the second part, part B, and because it has expected. In other words, out of 663, sorry, out of 1,663 are gonna play organized sports, and which is obviously 0.663 as a probability. Therefore, notice that don't choose A because say exactly, choose B because say it would be expected. Question number 15. This question will be longer, but just pretty much wording here. A gene composed of two alleles, okay, and these two alleles together is called genotype, and this is each parent has the same genotype as SS. One is uppercase S, which is dominant allele, and lowercase s, which is recessive, and you can read here dominant or recessive. Therefore, a allele can be either dominant or recessive. Uppercase S for dominant and lowercase s for recessive. Okay, now for the each parent has SS, or each person has SS, dominant and recessive allele, and this is the, let's say this is the father. Okay, father genotype is SS and mother genotype is again SS. Then each parent contributes one allele to his or her offspring. In other words, in the offspring could have dominant from father, dominant from mother, recessive from father, recessive from mother, dominant from father, recessive from mother, recessive from father, dominant from mother. Therefore, you have four possible outcomes that can have these genotypes on the offspring. Okay, pretty much this is the sample space here, and the first question says list the other two possible genotype of the offspring. They remember that the four possible genotype here, but the two instant you have these two. That's the question. Say there are two instances the offspring could have genotype SS. You see that? These two cases, offspring has SS, or SS means here is uppercase S, lowercase s, or lowercase s, uppercase s. There is two instant, but the other two instant you have uppercase S, lowercase s genotype, and therefore here in this question looking for list the other two possible genotype for the offspring. And in this question you have uppercase S, one genotype, lowercase s, other genotype. That's the answer. Part B of the problem. What is the probability that the offspring will have sickle cell anemia? And notice that if the person has genotype SS, that person has sickle cell anemia, because remember that lowercase s is going to be recessive sickle cell allele, right? Therefore, in this question looking for the probability that the offspring will have genotype SS. Okay, if the offspring has genotype SS, then the person has sickle cell enemy? And the answer is 1/4, because remember that there is 4 possible outcome in the sample space, and out of 4 there is only one here has SS. Therefore the answer is 1/4, which is going to be 0.25, and the probability is 0.25. That's the answer. And still we have other part of the problem. In 100 instance where both the mother and father have one dominant normal cell allele and recessive sickle cell allele, we do expect, see, expect here, because in terms of probability of the offspring, out of 100 you multiply 0.25 times 100, which gives you 25, and out of 100, 25 of the offspring to have genotype SS, because the probability that the offspring has genotype SS is 0.25, and out of 100, 25 of offspring we would expect to have genotype SS. Part C. What is the probability that the offspring will not have a sickle cell anemia but will be a carrier? Out of 4 outcome, the last 2 outcome has carrier but not sickle cell anemia. Therefore only SS, notice that uppercase s, lowercase s, lowercase s, uppercase s, these 2 genotype has carrier but not sickle cell anemia, and therefore the probability in this case is going to be 2/4, which is going to be 1/2, which is going to be 0.5. Therefore you put the probability 0.5. Like part B, in 100 instances you have 50, right? 0.5 times 100 is 50. 50 would expect, pretty much, we'd expect 50 of the spring will have carrier but not sickle cell anemia. Question number 16. In national survey, college students were asked, how often do you wear a seat belt when riding a car driven by someone else? And the response is given in the table. Remember that there is outcome never, rarely, sometimes, most of the time, always. In other words, 135 is a frequency. That means 135 people says they will never wear a seat belt when riding a car by someone else. Okay, now let's find how many people are in the survey. You add all the frequency, you got to find total number of people on the survey, and if you add all this total gonna be 4,698 are sampled for this question. And the first question is construct the probability model for the seat belt used by the passenger. In other words, what's the probability that the person says they never use the seat belt? In other words, you're looking for a probability of never. And how many say never? 135 say never, divided by 4,698. That's the total. And if you divide and round it to nearest thousands, which is 3 decimal places, you'll get 0.029. Okay, therefore the first box is going to be 0.029. Similarly, for the second box, to find the probability of rarely, you divide how many say rarely 338 out of 4698, which when you round it to 3 decimal places, that means nearest to 1000 is going to be 0.072. 0.072. Similarly, you find for sometimes, which is going to be 0.114, and most of the time 0.275, and always is 0.510. Okay, that's the probability of each responses. And part B is, would you consider it unusual? Notice that unusual event is the event which has a probability less than 5%. In other words, 0.05 less probability makes you event unusual. For who wear never seatbelt is 0.029. Is that unusual? The answer is yes, because the probability of never going to be 0.05. Number 17 is similar to the problem that we did before, therefore I will skip that. Let's do number 18. A bag of 100 tulip purchased from the nursery contains 25 red, 30 yellow, and 45 purple. Okay, and what's the probability that randomly selected tulip bulb is red? For you're looking for probability of getting red tulip, and in other words, you finding probability of red. And how many red on the 100 tulip? 25 divided by 100, which is going to be 0.25. Similarly, purple 0.45, obviously 0.45, because out of 100, 45 are purple. Therefore, the probability that randomly selected tulip is purple is 0.45. And here for part C, select the correct choice below and fill the answer boxes within your choice. Notice that in the part C, we interpret the part A and B probability. And as I mentioned in previous problem, we exclude this choice because it's exactly. Okay, exactly is not the correct interpretation in terms of probability. Therefore, we use expect. Okay, and therefore answer must be chosen A. And if 100 tulip bulb were sampled with the replacement, one would expect about 0.25 times 100, which is going to be 25 red, and 0.45 times 100, which is going to be 45 purple. Therefore, if 100 tulip bulbs were sampled with the replacement, notice that if you replaced, the number of tulip doesn't change on the bag. Therefore, here with the replacement is important word. One would expect about 45 purple and 25 red. And we put about 25 red, and we expect about 45 purple tulip. Okay, question number 9. A baseball player hits 57 home run. Out of 57, 21 to the right field, 16 to the right center field, 8 center field, 10 left center field, 2 left field. And if you add all this total, has to be 57 home run. And the first question is, find the probability that randomly selected home run hit to the right field. And out of 57, 21 went to right field. Therefore, the probability here is going to be 21 divided by 21 for A, 21 divided by 57, which is going to be, when you round it to 3 decimal places, that must be 0.368. For the second part, the probability that randomly selected home run hit to the left field. Out of 57, only 2 went to the left field. Therefore, the probability here is for B 2 over 57, and when rounded to 3 decimal places, the answer is 0.035. 0.035. Okay, and for C, was it unusual for the players to hit the home run to the left field? The answer is yes, because this probability here is less than 0.05. Therefore, you choose the answer yes, because the probability of left field is going to be 0.05. Don't get tricked by part D because say 0.5. That's not correct. For the unusual, probability must be less than 0.05. Okay. Question number 20. I think you can finish yourself. This is similar because sample space is given. You're just looking for the probability of the family with exactly 2 male children, right? Let me finish that for you guys. Exactly 2 male children out of how many outcomes? 16 here, because remember that is 4 in each event. There is 16 total. Out of 16, exactly 2. How many exactly 2? Male. Let's find it. Exactly 2 male. Here, 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 here. I'm looking for 2 pretty much. Right. Therefore, 1, 2, 3, 4, 5, 6. 6. Okay. Therefore, out of 16, 6 has exactly 2 male children. Therefore, probability of exactly 2 male gonna be 6 over 16. And if you reduce that, gonna be 3 over 8. Notice that here answer must be integer or simplified fraction. Unlike previous question, we use a decimal. It doesn't say rounded to certain decimal places. It says type an integer or simplified fraction. Therefore, the simplified fraction must be 3 over 8. Okay, question number 21. A single die is rolled twice. The 36 equally likely outcomes are shown to the right. Remember that if you roll 2 single die twice, you have 36 outcome here. 1, 1. What do you mean over 1, 1? First die is 1, second die is 1. 1, 2 means first die 1, second die 2, and so on. Therefore, there is 36 outcome. And the question is, find the probability of getting 2 numbers whose sum is less than 17. Notice that here you have 2 numbers, 1, 1, 1, 2. Every order pair has 2 numbers. If you add, you get 1 plus 1, 2, 2 plus 1, 3, and so on. And every sum are here are less than 17. For out of 36 outcome, all 36 sum are less than 17. Therefore, the probability here going to be 36 out of 36. 36 are less than 17. You divide 36 by 36, is going to be 1. And the probability of getting two numbers whose sum is less than 17 is obviously 1. Okay, last question, number 22. A table below shows the education attainment of the country population age 25 and over. Use the data in the table expressed in million. Remember that all is million, like 12 million, 26 million, and so total people on the sample is 172 million. Okay. And in the question, you're going to find the probability of randomly selected citizen age 25 or over had 4-year high school only. Here, 4-year high school only. Here is the 4-year high school only column. The 58 million has 4-year high school only out of 172. Therefore, what we're doing here is 58 million. You don't have to write the million because the million cancel, divided by 172 million. That's the probability. In other words, out of 172 total people on the survey, 58 million has 4-year high school only. You can see here total of this column is 58. And pretty much this is the answer, but in the answer you have to type integer or fraction, and you notice that you can divide by 2 to reduce that, right? Divide by 2, you get 58 divided by 2 is 29. Divided by 172 divided by 2 is going to be 86. And that's all you can do is 29 divided by 86. Okay, that's all about the homework from section 5.1. I hope you get help when you do the MyLab math homework. Thank you for watching the video.